So in this lesson, we're going to look at the graphs of trig functions, and specifically we're going to look at the sine, cos and tan graph, and we're also going to look at related trig graphs, also known as transformations of trig graphs. So we're going to see those trig graphs moving left, right, stretching. Let's start by looking at an exam tip. So if you see sine, cos or tan in any type of question in your exam paper, the first thing you need to do is make sure your calculator is in the correct mode, because there's most likely going to be a combination of questions in degrees and questions in radians in your calculator. So just get in the habit of always checking, because undoubtedly you'll have to switch between the two in your exam. If the question is in radians, and we dealt with radians in a previous lesson in this trigonometry module, with radians there's often a pi floating around. We often talk about radians in terms of pi. And so that's kind of your hint in an exam. It will often not even say the word radians, but you'll see that there's a pi in the question, and that's a hint to you that you're working in radians. So there's instructions here. You can pause and have a little look depending on which calculator you have to make sure you're familiar with switching from radians to degrees and back again. Sine, cos and tan graphs. We're going to start by looking at the sine graph and the cos graph. Graph of y is equal to sine x and y is equal to cos x. So this first one here is the sine graph. You'll notice that it goes through 0, 0. It has this lovely, what we call sinusoidal wave, as does the cos graph. Now, they might look identical at first glance, but if you look a little bit closer, you'll see that the sine graph goes through 0, 0, and the cos graph goes through 0, 1. After that, they follow the same kind of nice up-down pattern. So for your graph to do one complete rotation of up, down, up, and back to the starting point, that distance here along the x-axis, this is called a period. So the period here for sine is 2 pi being the same as 360 degrees. And the cos graph, again, the period is 2 pi. Here, the period is drop down, back up again. And once you get to this point, it's like the graph repeats itself over and over again. So one period here is also 2 pi or 360 degrees. Here's the sine graph and the cos graph on top of each other. So you'll see that the cos graph is the blue one, goes through 0, 1, and the sine graph goes through 0, 0. So they're actually the same graph, but just shifted a little bit off. The graph of sine x and cos x have a maximum of 1 and a minimum of -1. Now we'll see later on when we do transformations of these graphs how that will change, but your basic sine graph and cos graph go from -1 to 1 on the x-axis. We already said that they have a period of 2 pi or 360 degrees. You can see that there. And they are periodic. That means they repeat. So every 360 degrees or every 2 pi radians, they'll repeat and start all over again. So then the tan graph looks different. The tan graph doesn't have that nice sinusoidal wave. It has got these discontinuities. Now, if you type tan of 90 degrees into your calculator would probably say math error. So that's where the discontinuity is. You can't actually find tan of 90 degrees. The reasons for that are more than we have time to go into here, but tan of 90 degrees is what we call undefined. So undefined at 90 minus 90, 270 minus 270. And so at this point, where tan of the angle is undefined, we call these dashed lines, they're like invisible force fields that the graph gets closer and closer to, but never actually touches. We call those lines asymptotes. Now, we're going to see asymptotes in lots of different graphs, not just in tan graphs. So you can see here we've got our angles are in degrees, but 90 degrees would be pi over 2, and 180 is pi, and 360 would be 2 pi. So what is the period here? This one repeats every 180 degrees. Let's see. If we were to start from 0, it's going up there, but then it starts again from down low and coming up there to 180 before it's back on the x-axis and starting to repeat going up again. So it is periodic, repeating every 180 degrees. One thing to notice in these graphs is that they also go into this negative x-axis. So you could have tan of minus 90, tan of minus 180, and that's a concept that we didn't deal with when we were dealing with triangles, because of course with triangles, the angles always have to be positive. There's no such thing as a negative angle in a triangle. I'll just go back for a second and show you the same thing on the sine graph and the cos graph. Even though we can't find sine or cos of negative angles on a triangle, in theory, and when we're looking at trig graphs, we can actually go into negative angles, negative values of x. Okay, so that's just a brief summary of the sine, cos, and tan graph. Nice short video. Come straight back on for the next video where we're going to look at related trig graphs.